Hey guys, in this video we are going to walk through the existing and proposed hydrology basins and show you how to delineate that both on-site and off-site. This is important to do in the beginning stages of the project so that we can get an idea of roughly how big our ponds need to be and what off-site drainage areas we may need to account for. So let's learn. Hey guys, welcome back. Today I'm going to show you how to draw a drainage basin for existing and proposed site. And here we're working on this Probasco site, and so we want to think about on-site drainage areas and off-site drainage areas. So the on-site is going to be the easiest. I'm just going to select that boundary of that property right there, move it over 2,000 units, put this on the hydro existing, PW10, move that back 2,000, and then I would recommend either picking like a hidden 4 or a stripe X8, maybe make the line type bigger, and it should probably be a lot thicker than that. So that was a PW10, I'll make PW20, so that when you put this in your hydro report and this thing's showing up on a single 8.5 by 11 sheet, this stripe line should be very easy to see. So make sure that that's nice and thick. So there is the existing. Then we have, I've shown you with these arrows where we've got water coming into the site and in a few places around the property. And in order to help delineate the off-site, we need to find high points and the saddles, and we have some documents that talk about how to draw drainage basins and how to find the saddles. And so you always start from the low point and work your way to the top. So for instance, here's a hilltop, and water flows off in every direction from the very top. And so you could basically draw a line in any direction you want. There is no one right answer for which way the drainage basin goes. So in order to draw an accurate drainage basin, you need to work from low points up to the high point. And so an example here is this saddle. We're going to start from these saddles and then work our way up to the high point. And I'm going to delete these so that we can do them together. So I'll start with a polyline. I'll start in this saddle, and it's basically going to go like that. And then from this saddle, we're going to go up at perpendicular angles, perpendicular to these contour lines. Let's go off in this direction. And I think this is going to go, there's a water tower here, I think it goes right to the midpoint on that. We'll check that in a minute. We'll start at this saddle point, come up perpendicular to each of these lines. So there's a bunch of saddles in here, which is good, so that you guys can see. So you don't want to go this way because then it's crossing these lines not at a perpendicular angle. You want to go this way and then this way so that it's crossing each contour line perpendicularly. So essentially what's happening right here is we're kind of coming up from the side, we hit the ridge line, and there's like a little ridge line right there, hit the ridge line, and then it goes up the center. And then for this property, we can start at this low point of our property line to see, well, really this water could be coming in here too. We could start at this corner of the property and then just work our way uphill. And then let's do that here as well. This goes out to the street. So they have this neighbor has a driveway there. I'm just going to assume that the water in front of that driveway goes out to the street, and I'll draw a line kind of going up on this side of the driveway. Okay, so now I've put that basin in there. I'll get rid of these highlights. Oh, we wanted to check this. We're missing a little bit of contour data there. I've gone ahead and pulled up this county, Walker County, Georgia, just to check what's going on this little area that we don't have topo for, and you can see that, you know, from this low point the saddle comes up to that water tower, and then it comes up this way to the water tower. So that is basically what I've drawn there, so I think that's accurate. These guys, let's just put them on the proper layer, and I'll stitch them together as well. BJJ. Yeah, all of those are connected so far. Okay. And then we'll put them on that layer. PW20. And you can see that the line type starts over at each of these nodes, and only when there's a big gap between nodes do you actually see the line type. But I want this line type to generate continuously, so I'll type PG, generate continuously, yes, and then that makes it look better. Alright, now we can isolate that. So we have that boundary already. Let's connect this in there. And that's not connecting. Looks like we started with an elevation of 832, so let's move that to the 0 elevation, and yes, now that stitches together. And then I'll use the command BP for bpoly, and that didn't work exactly. I wanted it to be just this area outside the property. Let's try that again. bpoly. And there we go. So now, actually, I can just go ahead and delete that outside one. I can delete, well, let's leave these in there. These squares are just a remnant of using that bpoly command, so bear with me 1 second while I delete those. And then there is the off-site area that's draining on-site. PG, generate continuously, PW20. Okay, so now I have our off-site and on-site areas. We'll go down here and grab this drainage basin one. The volume, we don't really need to worry about that for now. The volume is, I'll show you how to estimate in another video how to estimate the volume. But for existing condition, there is no pond volume, so we'll just delete that. And then we'll grab this item right here. Generally make it as big as you think might fit in there. And we'll call this existing basin. The area is 18.3 acres. 18.3, time of concentration for something like this, I'm going to guess 10 minutes. Usually it's going to be between 5 and 10 unless it's a really big site. You really want to have your time of concentration as close as possible for your pre and your post. That's going to help make the hydrology ponds a little bit smaller, but it needs to be indicative of what the site is. So I'm just taking a guess now because later on we'll go through and calculate exactly what that is when we're doing our hydrology. And the curve number, I'm going to say is 55, which is a good default. A lot of cities around Georgia make you use 55 no matter what it is. And impervious, I'm going to say 0%. Okay, and then this guy, same thing, 35.45 acres. Existing off-site, 35.45 acres. This term of concentration, it's a bigger area, so I'm going to do maybe 15. Impervious is 0, and the curve number is 55. So that should accomplish what we need. That is your basic existing condition hydro basins. But if we want to break this up a little bit more, since we have water coming in different places, so that we can get an idea of how much water we need to pick up, we could draw some lines in like this. I should have made this a polyline to begin with. So there's the center line of that basin. Looks like, I'm going to say this is the ridge line here. PL there's kind of a knoll. So once you get up to that knoll, then you need to go this way. So there's that one, another knoll here. Another one here. And then this water kind of just passes through, but then eventually comes in this way. So I'm going to leave all of this together because really all of this is going to combine and come through this area. So there's our quick example of how to draw the existing basins, on-site area, off-site area, and then let's think about the proposed condition. So I've identified a stormwater pond there and a stormwater pond there, and this one is going to be able to be a lot bigger, so I'd like to push as much water around to this pond that I can. This one's going to have to be more shallow, and it's a triangle, which doesn't hold as much area as a rectangle. And we've done some rough grading already, you can see, and water could come through here, but our pad grade is going to be up closer to 70. So I could run a pipe from this 70 kind of around the corner and into a pond down there, and that would work fine. So CG, utility, storm. So I think we could capture all of this and push it around there. So maybe we use this high point as our ridge line for the proposed condition. And I really don't need to trace the existing contours because we're going to redo all of that. But why don't I just cut between these? Actually, we're going to have a little high point right there. So let me get and a high point here. So let me go up one lot, and we'll make this kind of our basin line. And then if I grab our boundary and that, move this off to the side, and I'll use that Command B poly again, do one there and there, put both of these guys on the C, where is it, CZ hydro post, CSPH for proposed hydrology, CSPH, and let's make those PW20 as well. Get rid of that little line in there. Maybe these we make stripe X8 so they look a little bit different. Increase the line type to 10, and then we can move this back. There it goes. Okay. So those might be our two proposed basins, and again we can come down here, grab this, make this bigger. I'm going to do 30 for the height, put that on the same layer, and I'm going to call this one South Basin. TC is 5, which is a good number to use. And this area, AAA, is 9.6. 9.6. And that, it just rounding it to the nearest tenth is fine for these conceptual purposes. 8.7. We'll get, because we really don't know where this delineating line is going to be until we start laying out our storm pipe and whatnot. But for now, we just want to get a rough idea. And we'll call this one North Basin. And I already forgot what the area was. It was 8.7. 8.7. And the CN is 70. Let me show you one other thing from our support company policy preliminary and DD pond size chart. We're doing 12,000 square foot lots, and so R15 would be 15,000 square foot. So you can see we're going to be somewhere between 7.5 and 15,000 square foot lots, which for type B soils is curve number is 69. So if the lot size is going to be a little bit smaller, the curve number is going to be a little bit higher. So I think curve number of 70 is pretty realistic. And so that's why I picked 70 there. Now we can also go into our pond design chart and look at the runoff coefficient. Type B soils, do some good open space and some impervious, and I don't know what the ratio is. Let's just say that this one is equal to 1 minus whatever that one is, and let's see what we can figure out to get that curve number to be 70. So if I go to data, what if, goal seek, I want to set this cell to 70 by changing that cell. It looks like 24% impervious and 76% open space gets us a curve number of 70. And so it will calculate your percent impervious right here. Most of the time this is not an exact acre, and so you'll want to look over here. So this is 24%, and so now I can just put that right here. 24% impervious, and let's enter that on this one as well. And so now we've done our pre and post CSEH, pre-basins, and CSPH, our proposed basins. And that's a quick overview of how to draw the pre and post basins, and stay tuned until next time. Thanks. I'm going to do a quick addition to this video. Since we put in 2 proposed basins at the very end, CSPH, and I split them into north and south, we really need to have a north and a south for the existing basin. So CS and then EH for existing hydro. And so I'm going to split this along this ridge line here. And we'll come up this way. And then let's change this to existing south. And existing north. And I'm going to grab these 2, move them over 6,000 units, B poly for that one and that one. Move 500, just so that I can match properties from this guy to these 2. PG, generate continuously. PG, okay. And then I'll move these back 5,500 to the site, delete that. And so that's this existing north now is going to be 9.1 acres. 9.1, and the south 9.2. And there's our modified north and south pre, and then CSPH, our north and south. And these are, again, just very conceptual. We're doing this at the beginning of the project. It's going to get refined more when we get into the hydrology study in the end.